thanks so much for joining us again with Conversations with Cliff. My name is David Evenden, the owner and founder of Standard User Cybersecurity and the Standard User Institute. This is my good friend and president of Standard User Institute, Cliff Lash. Hi, Cliff.
Hi, David. Good to see you.
Good to see you too. Thanks again for joining me.
Yes.
Yeah.
Okay.
So in the past few weeks, we've talked about introduction to cybersecurity, differences between information security and cybersecurity, man-in-the-middle attacks, and
Denial of service.
Denial of service. Thank you so much. Yep, DDoS and botnets attacks.
Botnets and zombies.
And zombies. Yeah. So it's been a really good challenge for me and been really fun.
Yeah.
So what are we talking about today?
Today we're gonna look at three different things which are kind of related, but they're under the heading of malware, viruses, worms, and Trojans. And I want to say just a little bit, as I've said in other times that we've met, I've been reading the book Cybersecurity for Dummies, written by Joseph Steinberg. And one thing he says in the chapter on cyber attacks, he says, many different types of cyber attacks exist. So many that I could write an entire series of books about them. Okay, and so he's just got one chapter that just kind of goes into some of the big categories, but it just kind of blew me away that he actually said he could write a series of books on the number of cyber attacks that are out there. Right. And I think a lot of times when we're looking today at viruses, worms, and Trojans, we kind of use viruses as the big category and think that covers about everything, when in reality, malware is the larger category, and virus is one category underneath it. And in some ways, viruses, and we talk about antivirus protection, but virus is only one category of malware, and maybe not as dangerous as many of the others. And yet we think of viruses as the main thing. Right. And so I'd like to look at them kind of individually, viruses, worms, and then Trojans, and just kind of let you tell us what they are. And I have some questions about them. So you want to start with viruses?
Sure, yeah. Well, I think talking about these individually is great. However, I also think that talking about them as a whole is probably more important. And okay. I'll tell you that why here. And let's back up for 1 second and let's talk about cyber attacks.
Okay.
Now a virus, a Trojan, and a worm are not cyber attacks. They're what we call in our profession as payloads or embedded agents or callbacks or different things like that.
Well, they do attack your system. I mean, if you get them into your computer, they do damage to your computer.
Yeah. Well, you know, again, we're basically using different types of terminology to express similar things, and to attack a computer, and again, it kind of depends. To attack a computer really is the idea of either degrading functionality or gaining access, the act of gaining access. In my opinion, and I think a lot of cybersecurity professional opinion, that's the actual attack. The process once you get in, and we might be, you know, we're probably talking about very similar things here, but again, using different types of terminology to express it. A cyber attack would be, it could be present continuous, so it can be, you know, a piece of malware can be part of a much larger cyber attack. But in my opinion, a type of exploit might be, the act of gaining access might be that process.
Okay, so can I ask a specific question about viruses? Okay, one thing that viruses do, they or can do, they attach to the root system of your computer and then just kind of do damage to your computer, causing it to run slow or other things. But so one thing is just it's just causing mischief inside your computer.
Sure.
But I think I also read that viruses can also create like a back door so
Sure.
that someone else could gain access. So if it's doing that, then wouldn't that be kind of an attack?
The virus of the making your computer slower is more of the attack.
Okay.
Yeah, so that's a perspective. So again, kind of going back to what I was saying, if you talk about an attack being a process of exploiting or gaining access or degrading service, so let's just define it like that. That's what, in my opinion, what attack would be.
Okay.
Now, once you get and in certain conversations, an attack can be the entire process. What's your goal? My goal is to capture this intelligence and bring it back. So the entire aspect of gaining access, persistence, migration, movement, that whole life cycle, it could all be part of the attack, or the exploitation of the cyber attack life cycle, if you will. So when we move back down to what might be considered a payload or an embedded agent, or a piece of malware, all sort of very similar depending upon what their functionality is, that's really the key element of the payload. What is it doing? How is it being accessed or used? So so really, again, what you're sort of talking about here are differences between automation, overt and covert, and propagation are kind of the types of aspects of what we're talking about here. So do you care about being hidden? And if you don't, that would be more overt activity. So so for instance, a worm might just spread, be as noisy as you possibly want it to be, and that's overt activity. It's moving throughout a network. It might be trying to accomplish a specific task, might be looking for a specific computer, or might be just performing a specific type of activity. For instance, ransomware can gain access to a machine and do it all completely on its own and just propagate throughout an entire network, locking everything down. And
Okay, so stop just a second, because in a future episode, we're going to talk about ransomware
sure, yeah.
and key logging.
Yeah,
But you're also saying that ransomware can come in. That's how it gets into your system, is through a worm.
well, I would say that no, I would say that ransomware can be perceived as a type of worm.
Okay.
Yeah, in my opinion, depending upon how it's designed, how it's configured. If there's a person with hands-on keyboard and they're the person going from machine to machine installing the ransomware, then I would not categorize that ransomware as a worm. I would, in my opinion, I would categorize some type of an embedded agent that automatically propagates from machine to machine, performing some type of action as a worm.
Okay.
It does it on its own.
Yes.
So moving back to a specific type of virus, and you kind of alluded to that. If you gain access to a machine and you're doing something to reduce the functionality or capability or service of that machine, to degrade it of some kind, that, in my opinion, would be a virus. Like same thing that would happen to a human being if it gains access to it and it like makes you sick. So
Yes.
essentially, a virus would make a computer sick. Now, and I am using the word malware or embedded agent or something like that you might be used. Those are more I don't want to say like professional tier words, but they might be. I have no idea. So we're using virus and worm, and what was the third one that you mentioned?
Trojan.
Trojan, yeah. So Trojan, essentially, I think a Trojan would be probably the most common type of embedded agent, if you will, that I'm familiar with. And so let me sort of describe that to you. about what I would do if I was gaining access to a target machine and I wanted to be covert, where I don't want my activity to be seen and it's hands-on keyboard. It can be an automated C2 where it calls back and performs some function on its own, but again, the focus being covert activity. So let's just say, for instance, you download an application and that application is installed. It's a real application. You paid for a license for it, yada, yada, so on and so forth. And it has an installation path. It's installed as your user, and it runs as your user. So you don't have elevated system privileges or anything like that, administrator or system privileges on your machine. And I get on your computer, and the installed application that you've got on there has its own registry key and the whole deal. And all I do is I take your existing installation path and I drop an executable in that path. An executable being a process, something, some type of a element of code that's been compiled to run as an application. And I drop that into the path of your existing installed application. And I rename it. It might be called, let's just say, for instance, a common one that you see a lot might be called Adobe. And in the installation path might be called Adobe Sysfont.fnt. And so if I take that file, Adobe Sysfont.fnt, and I put another file in there, executable.exe, and I call that Adobe Sysfont.exe, and I match the timestamp, so the timestamp that it was created, the timestamp that it was last edited, the whole deal, and it looks exactly like the existing file that was in there before. Now, of course, there's ways that in forensics that you can actually notice this or find this type of activity, but the idea is that, to the regular human eye, you go and look at that, you can't really see any major differences. And so now I take your existing registry key and I replicate it. I create a new one, and that registry key now calls my executable. And what that executable does is now calls back to a command and control server, which might produce automated commands to run. And those automated commands run, produce some type of output, and send that output to the C2 server. So say, for instance, I want to look at your computer, and I want to see what is the IP address, what is the host name, what network is it part of, what's its public IP address, where in the world is it geographically located, do you have any VPNs, do you have any installed email addresses, yada, yada, yada. Do you have stored passwords, do you have financial information? Whatever my goal is within the targeting of your computer and your network, I want to capture that information in your local machine. And so, it might run those commands, send them back to the C2 server, and store it. And so as it stores it, then now you have the entire life cycle of what I call an embedded agent. Other people might call malware, other people might call Trojan. They're sort of all different types of, again, like sort of what you implied, terminology. So, but really the perspective is that a Trojan would be a Trojan horse. It's pretending to be something different. It's pretending to be something different than it actually is. While a virus or a worm really don't necessarily care too much about covert activity. They just care about performing their specific actions. I would say that the majority of APT activity, or advanced persistent threats, generally speaking, nation state actors and other highly funded crime syndicates, if you will, terrorist activities, highly funded terrorist activity might be considered advanced persistent threats or cyber advanced persistent threats. They would use a type of Trojan to gain access, and what you would really call there is, you might hear the word RAT. So a RAT is a remote access Trojan. Again, coming back to the idea of an exploit or a cyber attack, you gain access, you install some type of piece of malware, remote access Trojan in this case. And this first step of throwing the exploit, what if that exploit goes away? What if the ability to re-access that? What if they patch or upgrade their system or remove that piece of infrastructure, and now you no longer have that access? So the remote access Trojan provides you access immediately to that piece of machine, to that embedded agent, or that computer, if you will, and you no longer have to try to exploit, you already have access in there. So the best way to think about that, for instance, and of course I'm not calling Microsoft an APT or RAT or anything like that, but in that same way, you would have a Microsoft application installed on your computer, and it needs to get updates. So what does it do? It calls out to a server, an update server, gets its updates, pulls them down, unloads them. It says perform this other types of actions, and it does that. So in the same exact way that application might call out, perform some type of action, your remote access Trojan is also doing the same thing, pulling it out, doing something, and performing some type of action. So that's sort of the life cycle of what the different elements of a virus, a Trojan, and a worm might be.
Okay, so back in the category of viruses, I read that one way sometimes they're embedded as macros into like Word documents.
Yeah. So again, what you're talking about are delivery methods.
Yes.
Of a piece of malware. So again, let's talk about malware at the top, and you have virus, Trojan, and
Worm
or
other
rat or whatever else, any other type of terminology. So the macro of a Microsoft Word document is a delivery methodology for a type of malware. It could be any type of malware you want. Again, it depends on what the goal is, how it performs its functions, and really what's its accessibility and whether or not it's automated.
So these Word documents, I mean, they're not something that a friend sends to you. They're something that someone has put the code into, and you open it somewhere. I don't know from where.
Right. We're kind of getting off topic from the virus and the Trojan and the worm.
Okay.
But to explain it to you, since you're asking, the way that would happen, a friend could send it to you unknowingly. It could forward you a Microsoft Word document that they've received from somewhere else. For that matter, it could be a PDF document with some type of embedded exploit or anything in it like that. An image that's been like re-encoded, for instance, with Stegosploit. Stegosploit is a methodology to interact with the layers of pixels in a JPEG or any type of image, where it can throw an exploit or install something, perform some type of an action. And so what would happen? Yeah, somebody, a specific type of attacker would open up a Microsoft Word document, go into macros, install or type out some type of an element of macro that either runs a piece of code to perform an action or downloads and installs something. Now, macros in general are not enabled by default. So you have to go in, if you get that in your computer, in order to see the code or in order to see the elements of the file, that's extremely important that you have to view now. You have to go in and enable macros. And so that's a manual process. It's got a little tab at the top of it and says click and enable this. So it's not something you're going to unknowingly do, but it doesn't have to just be a Microsoft Word document. This can be, they can be embedded into PowerPoint documents, Excel documents, any type of Microsoft element that has macros as an element of their application.
Okay. All right. Well, one thing about, I mean, Trojans do not self-propagate.
I would say generally that's true. I think so. But that's not a hard, fast rule. One thing that you're going to learn very quickly in the cybersecurity industry, there's no such thing as a hard, fast rule.
Okay.
In fact, the cybersecurity industry exists because there's a bunch of rules that people are running around breaking. It's like, and it's not like the law. I'm not talking about like, okay, this is the law, don't run around and break the law, although that is the case. But I mean, curiosity begets people trying new things. I wonder what happens if I want to get this file on this computer, but I'm not allowed to browse out. Can I embed a macro in here, download this file so I can share with my friends?
Yeah, I mean, I guess if things were not constantly changing, our antivirus software from 2005 would be all we need.
Exactly right. Yeah, but the world and the element,
Yeah,
every rule that exists within the information technology ecosystem changes all the time.
yeah, yeah. But under Trojans, I've read here in the cybersecurity for dummies, it says that the Trojans specifically, they rely on the effort, or more accurately, the mistakes of human beings. So it means clicking on those links. And I know, I mean, right this minute, I can find probably in my computer, in my email inbox, one or another that's got one from somebody that says, you know, something from a friend of mine, somebody I know, that has this link in there, and I know it's malicious software, they've been hacked or whatever, so I don't click on it. And sometimes I get things about I need to go update my accounts at a bank or a credit card. Those are malicious.
Mm-hmm.
And so we just keep getting these things. So what happens to people if they actually click on that? Are they like doomed and done for, or will their antivirus software go into effect and catch it before it does any damage?
Yeah, I mean, that's a great question. Again, you know, an entire another episode of Conversations with Cliff, but because you asked, the process of clicking on that, there are different elements that can happen. That click could be download something, and when it downloads, you double click on it and you run it, and now you have a piece of malware installed. It could be you go into a website, and that website viewing your web browser to see if there's any exploitable elements, outdated web browser, vulnerable operating system, and those have to be all paired together. It's not like just like, well, if I have version 5 of Internet Explorer, I'm vulnerable. Although there are some types of exploits and different types of applications that exist on every element, on every operating system with that particular application. But in general, exploits are paired with the operating system and the application. So you might have, a Windows 10 machine with, Internet Explorer 18 or 20,000 or whatever number IE is at now. I think that's actually Edge, but I think Internet Explorer still exists. But so you might have that different elements, and then you get to like, Windows 8, and you have the same version of Internet Explorer. That same exploit might not work. It might be the memory address space of Windows 10, where it interacts with Internet Explorer, might be what the vulnerable element is, and that might not exist in.
Okay, well, I think on this topic, since you say it's a bigger issue, we might say this. We might come back to this issue about what happens if you click on one of those emails accidentally. What happens? And we can make that a whole episode in the future. So what would you want to say? What else needs to be said, do you think, about viruses or worms or Trojans today? Is there anything we've left out or that needs to be
the last thing that I would say is basically like, in answering the second part of your question that you just asked, would my antivirus catch that and prevent it? The answer is maybe, or it depends. So if the type of virus or malware or Trojan or worm that is being delivered as the payload to your operating system has not been seen before and does not have any known heuristic activity of a known bad piece of malware, the probability that your antivirus is going to prevent that from installing and running and giving someone else remote access to your computer, the probability that that's going to be prevented is very low. So antiviruses work off of heuristic type of activity. If you're performing these types of actions, chances are you're malicious, or signatures. The process of performing different type of activity can be a type of signature, but generally speaking, a signature is going to be a hash, a file, a name, an installation location. A signature might be a domain name. It could be an element of code within the file. It could be what happens across network activity. There's a bunch of different elements of what can make up a signature for antivirus. Again, the elements that make up a signature for antivirus is an entire another conversation. But
Okay.
yeah.
Did I hear you use the word heuristically?
I did say heuristic activity. So the nature.
What is that?
It's basically how do you describe heuristic? I guess no one use a word, you just know what it means, but you don't know how to define it.
Yeah,
So I would say, yeah, I guess I would just say activity. The activity that an element that an executable or activity. So let's just say, for instance, you might have specific heuristics. You come in here, you get a glass of water, you go and you fill it up and you drink it, and then you put it away or you wash it out. And you might do that by, and you're like dancing and whatever. Like those are all the heuristics of your process of doing that activity. So
it's kind of like the process of doing an activity.
Right, exactly. So in the process of doing a specific activity within a process, an ENAXE or computer-related process, it might be interacting in this particular piece of memory address space, or even capturing or running something with your cmd.exe or /bin/bash or sh, your bash shell or something similar to that, where you're running a process. So if you run a process with another executable from within an executable, if you carve out all of the extra space of a process, which is called process hollowing, and you inject a piece of code, process injection, into an existing process, or you migrate from process to process, those are all activities that might be considered malicious heuristic activity.
Okay.
Yeah.
All right. Well, David, thank you very much. This has been extremely enlightening. I love these conversations and I learned a lot, and I hope they're helpful to other people as well.
Yeah, that's awesome. Thanks so much for joining me. And we'll see you guys next time on Conversations with Cliff.
All right. Thanks a lot.